Okay, Chapter 5 study guide. I recommend that you do these in your notebook as there's not much room on the study guide. So this first question says to calculate the x-intercepts. Show all your work. So remember your notes. The y-coordinate for all x-intercepts is 0. So if I replace y with 0 and solve for x by factoring, I will find the x-intercepts. So remember, standard form is y equals ax squared plus bx plus c. So this is missing a term. So I'm going to add 0 for the constant that is missing. So this is going to be y equals 15x squared plus 5x plus 0. There is a common factor of 5. However, you can do this without factoring that out, just because the 0 is going to make life easier. So let's factor this using an area model. 15x squared, remember your x squared term and your constant go in opposite corners, and you're multiplying these to put in the top of a diamond. You could just put 0, but I kind of like to put the x squared up there, and then the x term goes in the bottom. So you're looking for factors of 0x squared that add up to 5x, so you know one of them is going to be 0, or 0x. And then what could you multiply to get 0x squared, but when you add it you get 5x, 5x and 0x. So 5x and 0x, it doesn't matter where I put each one. 5x times 3x is 15x squared, and then 5x times 1 is 5x. So then this is going to factor into, oh, and 3x, I kind of skipped over that. 3x times 0 is 0x. So y equals 5x plus 0 times 3x plus 1. So same steps. I'm going to replace y with 0. We've already factored it, and that's going to give us the x-intercepts. So we're going to use 0 product property here. 0 equals 5x plus 0 times 3x plus 1. And then using 0 product property, if you have two quantities that are being multiplied to give you 0, then you know one of those quantities must be 0, or both are 0. And parabolas usually have two x-intercepts, so chances are it's both. Okay, you could subtract 0 from each side. That's just going to give you 5x equals 0. Divide by 5, so x equals 0. Subtract 1, so 3x equals negative 1. Divide by 3, so x equals negative 1/3. So those are my two x-intercepts. Okay, number 2. Solve the equation by completing the square. Okay, this is what we were doing with tiles, and yes, I'm going to use tiles, but you don't have to, although it doesn't hurt. I think the ones in the test are going to be small enough that you can use tiles. Okay, so we have x squared minus 6x, and then minus 1. So here's x squared. Here's the negative 6x terms, and here's the negative 1. So you can keep this negative 1 on this side, or you can move it to the other side. That's totally up to you. I'm going to move it over. What matters is that you make a square. And if you're going to make a square with this, you'd actually have to add an extra tile to get rid of this one. So I'm actually going to move this one over to the other side. So that's going to give me x squared minus 6x equals 1. And so I've moved this guy over here. What would make this a square? Adding 9 unit tiles would make this a square. Okay, I'm going to do this real quick in case you need this as a visual. Okay, so I'm adding 9, which makes a square. And if I add 9 to the left side, I have to add 9 to the right side. Now you might be saying, how could I do it without moving this over? You would just add 10. Negative 1 plus 10 would give you 9. And if you added 10 to the left, you would add 10 to the right, which is what you get either way. So whichever way makes sense to you, that's going to give me x squared minus 6x plus 9 equals 10. And then the whole purpose of doing this could not be factored. If I were to use an area model with x squared minus 6x minus 1, I would not be able to find factors of negative 1 that add up to negative 6. Now, as I say that, I think actually maybe you can. No, you can't. Not negative 1 that add up to negative 6. Just kidding. Okay, so the whole purpose is to make it something that I can factor. So now I'm going to look at this and ask myself, what is the length and what is the width of this square? The length is x plus 3, and the width is x plus 3. So then this is the sum as a product. This would be x plus 3 squared equals 10. And I'm just going to solve that by taking square roots. So opposite of squaring, take the square root. That gives me x plus 3 equals plus or minus square root of 10. And then I'm going to subtract 3 from each side, which is going to give me negative 3 plus or minus square root of 10, and I'm good with that. You can check it on your calculator if you want. We've done some work with that. You can make sure you get it right that way, but if you leave it like that, we're good. Okay, number 3. Okay, we're going to find the x and y intercepts. Now that's kind of new. We haven't been really finding the y-intercepts, but that's easy. Show them as ordered pairs, sketch it, label the intercepts in the vertex, and get the vertex. So this is the Khan assignment. Graph quadratics in factored form. If you were wondering, what can I do to practice on Khan with number 2, this right here, all of this is completing the square. Okay, anything that starts with completing the square, and I would just focus on intro and intermediate. That regular completing the square is a little bit more than you will have to do on the test. And then this process here is solving quadratics by taking the square root. So anything that starts with this, all of those assignments would be good practice if you're struggling with any of this. Okay, so graph quadratic form is where you need to know your sentences and you need to know your notes. I am not going to coach you through this on the day of the test. Sorry, we've done so much with this, and you are supposed to be practicing with these sentences. You should know them. I'll probably have them posted, but if you don't practice with them, it's not going to mean anything to you. Okay, so let's start with our equation. Remember, this is just another way of saying y equals x squared minus 8x plus 12. So if my y coordinate for all my x-intercepts is 0, I replace y with 0, solve for x by factoring. That's going to give me my x-intercepts. So I'm replacing y with 0. I'm factoring using an area model. I'm using zero product property with those two factors to get my two x-intercepts. X squared and 12 in opposite corners. The product of those two is the top of my diamond. The x term is the bottom of my diamond. 6 times 2 is 12, and if I make both of those negative, that will add up to negative 8. So negative 6x and negative 2x, those are my missing terms in my area model. And that's going to give me 0 equals x minus 2 times x minus 6. Now I'm going to use zero product property and say if x minus 2 times x minus 6 is giving me 0, either x minus 2 is 0 or x minus 6 is 0. And then we're going to solve for x. So if I solve for x here, I get x equals 2. Here, x equals 6. So now I go to my graph paper and I graph those two x-intercepts, positive 2 and positive 6. And you do have to label them on the test to get full credit. You have to label them as an ordered pair. Okay, and then look at the second sentence. Okay, now we're going to read the second sentence. Since I know the vertex is on the line of symmetry, I find the x-coordinate of the vertex, substituted into the equation to find the y-coordinate. So for example, here, my x-intercepts were negative 3 and positive 5, so I knew that my line of symmetry was going to be along this line, which is the line x equals 1. So I knew the x-coordinate for my vertex would be 1. So I substituted 1 into my equation, into x squared minus 2x minus 15. So that gave me, here's f of 1 squared minus 2 times 1 minus 15, gave me 1 minus 2 minus 15, gave me negative 16. So then my vertex is down here at 1, negative 16. So you're doing the same process. On this one, I know that the line of symmetry is going to be in the middle of these two x-intercepts, so it's along this line right here, and that all the points on that line have an x-coordinate of 4. That's the line x equals 4. So I'm just going to take 4 and substitute it into my equation. So that's going to be, okay, I'm just putting 4 in the place of x. That's going to give me 16 minus 32 plus 12, which is 16 minus 32 is negative 16 plus 12 is negative 4. So then my vertex, so the vertex is positive 4, that's the x value, negative 4. Now a lot of people are going through the motions on this and then you get to the end and you don't know what it is you have done. That is why you need to know what this means. You need to study this and practice it, and I highly recommend doing another round of graph quadratics in factored form on Khan to really feel confident that you've mastered it. Okay, so 4, negative 4 is my vertex. Now on this question, don't forget it did ask us to find the y-intercept, which Okay, that's not hard. We can do that. We've got our x-intercepts. We've got our vertex. The y-intercept is just where it crosses the y-axis. So for the y-intercept, you're going to have a point 0 something. So I'm going to do f of 0, plug in 0 for x, which is going to give me 0 squared minus 8 times 0 plus 12, which would be 0 minus 0 plus 12, which would be 12. So then my y-intercept is 12. And many of you noticed when we went around and looked at posters that the constant, that's always your y-intercept. And you can just use that to get it also. So then 0, 12 is my y-intercept. So way up here. So then it looks like this. If you want to put the point, let's see, that one's 1, 2, 3, 4. This is my line of symmetry, so 1, 2, 3, 4. There's going to be a point over on this side too. Okay, oh, and we need to label it, so 0, 12, y-intercept. Number 4 and number 5 are basically the same problem. You're just being given different representations. So number 4, write a quadratic equation that represents the table. Explain how you created your equation. You could graph this, but you don't have to. I'm going to go ahead and graph it just so you have a visual. Okay, I've got the point -7, 0. -6, -4. -5, -6. Let's see, did I do that right? -4, -6. So the line of symmetry must be right about here, because I notice it's going down, going back up. -3 and -4. Oh wait, I did something wrong, huh? -5, -6. 1, 2, 3, 4, 5. 1, 2, 6. -4, -6. Okay, right here. So then actually, the line of symmetry is in between those 2 points. So it's doing like this. Okay, and then -3, -4, -2, 0, -1, 6, 0, 14. And I'm going to stop there because I don't have enough room for the other points, and I really only need the x-intercepts. So my x-intercepts are -7, 0, and -2, 0. I'm going to use those to write an equation of this quadratic. So that is going to mean, so if I look at my notes, if I know that the x-intercept is 5, my factor is x minus 5. I got that from solving x minus 5 equals 0. If I know my x-intercept is -3, my factor is x plus 3. Now this one is simple enough that that's all you have to do. So you have x plus 7 as a factor, and you have x plus 2 as a factor, equals f of x. And you could actually leave it like that. If you want to multiply these together, you can. If you leave it like that, I'm okay with that. Okay, number 5 is basically the same thing. You're just given the graph. So let's see, we have now this one's going to have an additional step, which I probably should have done on the last one, but I'm rushing to get this video done. Okay, so for this one, we're going to put a times x plus 3. and then x minus 3. X plus 3 is the factor for this x-intercept. X minus 3 is the factor for this x-intercept. Now you might have said, how did you know you did this right? You could put that in your calculator and graph it, and you could get the table and it should match this table. So you could do that to check your work. I will tell you number 4 on the test. That's all you have to do. Number 5, you do have an additional step. So here we actually have a coefficient that is not, a leading coefficient that is not 1 on this particular graph. So I'm actually not going to multiply these out just to save a little time. I'm going to figure out what this is. This y-intercept is 0, 12. This would get you partial credit, but for full credit, you would need to solve for a. So I'm going to use the point 0, 12 to do that. I could use any point on this graph, but that's really the only one I can tell for sure the actual points. So I'm going to plug in 0 for x. I'm solving for a, so I'm leaving a alone. That's going to give me 3 times negative 3 times a, and then f of 0 is 12. So I'm going to put 12 for f of 0. So you're solving for this leading coefficient by plugging in the y-intercept. You could use any point, it's just that the y-intercept with 0 makes life easy. So 3 times negative 3 is negative 9. So we have negative 9 times a, equals, well, I just gave you one with a fraction, I guess. Yeah, okay, so I'm solving for a. That gives me, I'm dividing both sides by negative 9. So then a is 12 over negative 9, which reduces to 4 over 3, negative 4 over 3. So then my final answer is, I'm just going to put this in the place of a, f of x, or y, equals negative 4/3 times x plus 3 times x minus 3. And that's, remember you had a bunch on con where you had a leading coefficient that was a fraction. It was just a fraction that had been factored out, a common factor. Okay, number 6, solve the equation by completing the square. So we've got now I'm going to write this with a little space right here. I have x squared plus 12x so to make this a square, I am going to add how much? Now, if you're doing it without tiles, you know that you're just splitting up these tiles, you're dividing them by 2, and then you're squaring whatever you get. So 6 times 6 is 36. I would have to add 36 unit tiles to make this a square. So let's add this right here and add 36 right here. This can be factored very easily. So if I look at, whether or not it can be factored, doesn't matter. You have to do this one by completing the square. So if I look at the length and the width of this square, the length is x plus 6. The width is x plus 6. So then this factors into x plus 6 squared, and then negative 15 plus 36 would be 21. I'm going to solve that by taking the square root. That's going to give me x plus 6 equals plus or minus square root of 21. Don't forget that plus or minus. Now at this point, when we were doing this in class, we were plugging x plus 6 squared into the calculator and 21 into the calculator, and we were looking at where those two graphs cross. So it was a parabola and a horizontal line going through 21. And you can do that to confirm your answer. You do need to show the work algebraically. If I subtract 6 from each side, that's going to give me negative 6 plus or minus square root of 21. I'm good with that. If you want to plug these into the calculator, you can either plug in this, or you could have plugged in this. This for the first equation, this for the second equation, and where those intersect will be the same as negative 6 plus square root of 21, negative 6 minus square root of 21. Or you could plug in x plus 6 squared and 21 for the two equations, and they will also intersect at negative 6 plus square root of 21 at two places, negative 6 plus square root of 21 and negative 6 minus square root of 21. Okay, number 7 is something we have not spent any time on, but it's on the test. It's not too bad. Don't skip it. I know you probably are going to say you're going to skip it, but it's actually kind of easy. Esmeralda had trouble accessorizing her outfit, so she made these spinners to randomly select what she should add to the clothes she is wearing. Note that each fraction of the circle is listed within each section. So I'm going to do an area model just because I'm short on time to do both, and model all the possibilities. So I'm going to put on the bottom of my area model okay, it says she's going to have a third a chance of wearing a scarf, a third a chance of wearing a pin, and 1/3 chance of wearing a hat. So I'm just going to divide this up by thirds. And then she has 2 spinners, so the other side is going to be half a chance of wearing boots, tall boots. So I'm cutting it in half. A third a chance of wearing black sandals. And 1/6 chance of wearing short boots. Now I'm not going to fill all of these in because it's only asking me for a particular outcome. What is the probability that Esmeralda will add a scarf and boots, tall or short, to her outfit? So scarf, and then either the short boots or the tall boots. So I'm going to find this area right here and this area right here. Here's scarf and short boots. Here's scarf and tall. So if I multiply 1/3 times 1/6, that's going to give me 1/18. If I multiply 1/3 times 1/2, and you could use your calculator if you are not feeling confident with fractions to multiply those two fractions. 1/3 times 1/2 is 1/6. And then you could so if you don't know how to do that, you could just type in open parentheses 1/3 times 1/6, 1 divided by 6. There's 1/18. Do the same thing for scarf and tall boots, and then I'm just going to add those together. So 1/18 plus 1/6 is 2/9. So I know that's not the best picture of that, but hopefully you get the idea. So the probability of her wearing a scarf and boots, tall or short, is 2/9. Okay, get all your con assignments done. All of that is good practice for the test. and study. This is a big test. Good luck, everybody.